Okay, we'll get started again. I didn't say this in the beginning, but as I'm talking, and if I trigger a question, please feel free to ask it, because if I'm not quite explaining something enough, or you want to do something that's connected to what I'm talking about, we can do it then. There isn't going to be a question and answer period at the end of the day. I'm just going to fall over and you'll all go back. So now let's bring in some elements of design. So in the orchard world, we talk about the orchard system, which is primarily referring to the choice of rootstock, how much vigor is in a given tree, and thus how much room does it need. So we're talking about tree spacing here. So I've used a term high density. I've used the term dwarf rootstock. So there are trees that have as little as 20 to 30% vigor, and those types of trees definitely need to be supported. So they might be planted on a trellis or have a stake. And as you get into, and this is all referring to rootstock. So right now I'm mostly talking in the apple realm. Peaches are often planted on seedling peach rootstock, or pears are often much more vigorous. There are dwarfing rootstocks for cherry and some of those other things. But in the apple realm, that high density system is trees planted as close as 2 to 3 to 4 feet apart. And it's on a trellis because the root systems are not large enough, substantial enough to hold up that tree under crop load. And they're pruned and managed a whole different way. And the spacing, like I said, might be 3 feet apart in the row, and the rows are, let's say, 12 feet apart. As we get into bigger trees, trees that are like 40 to 50% vigor probably still benefit from having a stake. And trees that are 60, 75% vigor, that's things like MM106. So what you'll hear are some letters followed by numbers. The letters refer to where the research was done. And so MM stands for Malling Merton. It's a research station in England. So MM106, and the number does not refer to the vigor, and they're out of order. It's just the number that was given to that 106th tree in the row or whatever. But there's these different categories. As we get into bigger trees, we no longer need a stake. They have a more substantial root system, so they're more anchored, and they also have an ability to compete with other plants, much more so than the more dwarfing stuff. And so these trees are freestanding, and the pruning method is such that you are developing the wood structure for several years before you get into fruiting. And that's really the big distinction. Does it absolutely require support, or does it a freestanding tree? So an MM111 tree, which is like 75% vigor, they might be spaced 16 feet apart in the row, and the rows are 24 feet apart. So when I talk about design, I'm referring to some of that. So let's start with the very basic beginning point. You're planting one tree, maybe you're planting 6 trees, but you have this concept of, I want to create the ecosystem around them. So in a permaculture workshop, we might spend an hour or two designing a fruit guild. You would each, on paper, design fruit tree, and what are you planting in that guild that's going to support the health of the fruit tree, what's going to make a integrated ecosystem. So in that guild, and we're going to learn and go through some of these different plant choices, but like in this picture, there are things like comfrey and lovage. Lovage is a culinary herb, but it has that dill-like flower which attracts lots of beneficial insects. So different plants are chosen. Some of these are nitrogen fixers like goumyberry. And again, it's designing the ecosystem you imagine around that tree when that tree starts to bear. But what's often done, that's a mistake with this, is that little whip. Sure, you can plant a lovage plant a foot or two away, but when the tree's actually grown, that lovage will be deep in the shade, But in the early years, it's going to take nutrients from the tree. It needs to be 5 to 6 feet away. So this is always a little bit too crowded, but this is the idea of individual trees, or maybe an island of trees. Maybe there's 3 trees, and this idea of what plants are around that. So kind of starting with the garden approach. Now, this is a picture of a home vineyard, and the zone around the base of the grapes is managed with a deliberate planting of a chosen herb. In this case, it's a member of the Artemisia family. So Artemisia is chosen, one, because it kind of keeps out grasses and more annual weeds, but it also has a strong smell. If you're familiar with wormwood, you rub those plants. So it's thought to distract pests from finding what you're actually growing there. We'll hold on to that thought. If you are planting dwarf trees, and this is now, I'm talking more on I'm talking either a home orchard scale or a market garden scale. If you really want those smaller trees, which do not have the substantial root systems, and so you need to keep them more open, so in a chemical orchard that's done with herbicide, you might do it with a more complete mulching than the haphazard mulching I was talking about earlier. Planting such trees a row in the garden makes a lot of sense, because right next to the trees, besides the mulched maybe bed of 3 feet wide path, you're growing crops like peas that you might be mulching with hay, or at least cultivating to keep it open so no weeds crowd the peas. Or you're growing garlic, which you're shallow cultivating, or you're growing potatoes, which you're hilling. You're managing the ground to keep it more open. And often the crop, those peas, that garlic, is being harvested by midsummer, and if you're going to cover crop, that's the time when tree feeder roots have retreated. And so it ties really together. So maybe you cover crop with oats and a mixture of some other plants and things that winter kill, which means right next to your trees the next spring, you have this mulch that has died back. That's a biological herbicide strip. I never used that combination of words before, but you get the idea that what you're doing in the garden anyway helps keep the tree row more open. In a market garden setting, that might take the form of, I have a friend who has 3 rows of trees, and then approximately a 250-foot swath of annual cropping ground, and then another 3 rows of trees. What that creates is a lot of room for air to move around, as we're going to learn has relevance when we're talking about disease drying out after a rainstorm. So the design aspects, you're thinking about lots of different things, not just the aesthetic, but the efficiency of how you're managing it, but also what's going on next to the trees if they need more openness, and also airflow. This is the way most modern apple orchards are planted now, on more dwarfing rootstock, grown on a trellis to create essentially these fruiting walls. And the economic efficiency of this is really driven by the use of chemicals. So the herbicide strip is much less labor intensive than laying down mulch or cultivating. The fact that the fungal connection isn't going to be there in that herbicide strip to near the same extent necessitates spraying more fungicides to get to, or more heavy-duty fungicides to get through the disease season. Well, we're going to be learning that fungicides not only coat the leaf to kill the disease, but they drip to the ground, further killing some of the connections I've been talking about. So organically, what growers are doing is, rather than choosing trees in that 25, 30, 35% size class, the M9, the Bud 9, and some might work with that, but they're going a step up, but using the Bud 9 spacing, the 3 feet, 4 feet apart, because a more vigorous rootstock with some plants around it not necessarily trying to keep it totally open. Now think back to that vineyard example where we had the artemisias. The other plants are going to lessen the vigor, and the more vigorous rootstock thus is not going to outgrow its space. So that's kind of the basic concept. Now this term biological compromise. Another approach here is managing acreage and having a machine called there's one called the Wonder Weeder and another called the Weed Badger. And the principle is to shallowly cultivate the top inch or so of soil several times a year. That's not a fungal thing, that's a disturbance, but it's not tilling and cultivating like 4 to 6 inches deep, so it's not totally breaking up the mycelium. And that doesn't mean you can't put some wood chips as fungal food, or that you can't go in a more mulching direction. Right now I'm just trying to establish that these different systems can be accommodated, but you can still be thinking biologically versus chemically as to how you go about it. This is a picture, my friend Gordon Tooley in New Mexico has a deep soil shank plow, and he goes across the contours of the land. This is not tilling and breaking up all the ground and the potential mycelium of that grassland. Instead, it's opening up, following the contours, so that water can be distributed more evenly across. So in some instances, when you're planting an orchard, on scale, this kind of investment of getting the subsoil to be a little more aerated and open can be really helpful. So this notion of your look, think about forest edge thoughts, think about what's going on with the tree rooting cycles. This is a picture in the middle of our garden of an apple tree, and behind it are some raspberries. Now this is much more landscape look. I'm deliberately putting a less wild looking picture here to show you that you can go this direction. There's rhubarb growing on that one side of the tree. This is a more open tree, so it gets a little closer to the trunk. But the rhubarb is one of those really broadleaf plants with a dense, fat root. That means that under those broad leaves, where other plants aren't growing, there's a lot of room in that humus for feeder roots to interact. Now rhubarb I wouldn't go out of my way to plant a lot of rhubarb in an orchard. It's a non-mycorrhizal plant. It doesn't join into the party. But that's another use of something that if you make rhubarb pie, why not plant it to do that function as well in the orchard or under the fruit trees that you have in your garden. And then my wife grows peonies, which she dries. And so again, that looks a lot neater and it's more extensively mulched. In my actual orchard, it gets I call it a meadow ecosystem. But so your look, your choice of how you're managing those trees ties to the rootstock that you've chosen. And you may really want trees that only get to be 8-9 feet tall. On the other hand, my trees on rootstocks like MM111 and Bud 118, they could get 24, 28 feet tall, but I keep them to more like 14, 16 feet tall. But that works for that vigor. Again, we're getting really close to that Pandora's box of pruning. It works for that vigor if you know some pruning basics to contain it to that height. Similarly, a dwarf, I was talking to a guy who has a 30-year-old orchard on a rootstock called M26, which is like a 40% vigor. So that's something that you might expect to keep to 10 to 12 feet tall, and that would be a reasonable goal. But no one really pruned these trees, and they're like 28 feet high. It just was amazing. So depending on the soils and the climate zone, ideally you choose rootstock and get the appropriate spacing so you're not fighting this battle. But you're also letting in air. And a number of thoughts come into that. Like another part, when I said, I've been meaning to draw this slide, I haven't, so we're going to do it with fists. When I said my M111 rootstocks, which are in the semi-standard category, are 24 feet apart, but the trees are 16 feet apart. That means that each tree has an 8-foot radius, and that 8-foot radius around, and the 8-foot radius over here leaves me with a 6 to 8-foot tractor aisle. Well, it's not just about access, it's also about the fact that here's the sun, and the sun has to get over the height of this tree to get to the lower branches of this row. So there's a number of reasons why we don't just plant everything like elbow to elbow in every direction. We want aeration, we want access. All of that comes under the banner of orchard system. So now we're going to talk a little bit about soil fertility considerations, and we're going to start with compost, and then we'll get into some soil testing aspects that I think are important. So there's orchard compost and there is garden compost. And that's another way of saying there is fungally dominated compost and there is bacterially dominated compost. So typically, if you're a compost maker, your goal is to create a pile of organic matter that has a mix of nitrogen-rich material and carbon-rich material. So that pile has a carbon to nitrogen ratio on the order of 20 to 25 to 1. And no one measures that, but it looks like this. Nitrogen-rich material we'll call the green stuff. That's grass clippings, that's vegetable waste, that's fresh manure because it was green the day before. That's alfalfa meal in the winter when you need some more nitrogen to keep a pile thriving. And brown materials, carbon-rich, that's like fallen leaves, straw, even soil sometimes, so that's in a different category. But the idea is that you mix layers a few inches deep, a layer of green, a layer of brown, a layer of green, a layer of brown, and it achieves that 25 to 1 carbon to nitrogen ratio. So we make that for garden use, but that is what I use as part of the recipe to make orchard compost, where I'm going to make it much more woodsy. And I'm going to do that by adding the same volume of ramial chipped wood. This is sometimes where I use that softwood material. It could be fresh, it could be aged, and I'm going to combine it with my garden compost and then let it sit. So when we make my compost method, I don't have long windrows. I have these little Lincoln log kits, which is just wood, trees from the forest, and they're about 8 feet square, and we do the layering. And with compost, another thing to really plant in your mind, it's not just about replenishing nutrients. That's a part of the story. Maybe that's 40% of the story. The real emphasis is on creating microbe diversity to renew what's going on in terms of the soil food web, to invigorate. And so how you make compost, when you have that garden compost, and if you're certified organic, you have to turn it 5 times in 30 days. That's a really unfortunate rule. But the idea is to generate a bacterial explosion so it heats up. And that's how bacteria work. That's a good thing. But to just keep that going, to make sure you're killing all the weed seeds and potential E. coli pathogens. But often, when you keep that organic pile in a constant state of heat, it burns the life out of it. And so I do a more static approach. I don't turn my piles. I just pay attention to some brown and green. Another thing I'll do is I'll go into the forest and I'll gather leaf litter. It's not that I need the organic matter of those fallen leaves. What I want is whatever fungi is found on the forest floor, and I tuck it on the edges. So these piles sit on the order of 6 to 9 months. The nice thing about the logs is you can tear them apart, and then you can either get in with a wheelbarrow or your tractor bucket and scoop it up. And what's being used in the garden, it's rough compost. It's not totally broken down. What's being used in the garden, I drop it maybe a month ahead, and then I spread it. And that's kind of my aeration step. But the other half gets mixed with raw meal chipped wood, and I make piles that are accessible to the orchard here and there. My orchard is set up 3 acres in 3 different blocks. Well, it's getting there, but the time I use it on the garden. And it is absolutely starting to get there by the time the orchard compost pile sits another 6 to 12 months. And what you're going to see with those wood chips is a greater amount of aeration, and you're going to see these white hyphal strands in that pile. Now, you're not seeing mycorrhizal fungi, and 2 reasons. 1, they're invisible, so these are decomposition fungi. But 2, mycorrhizal fungi are a union of the fungal realm with plant roots. There aren't plant roots in a compost pile. I mean, there's decomposing roots. Unless you deliberately grow something in that compost pile, mycorrhizal fungi are not there. Make that distinction. When you spread compost, you're not spreading mycorrhizal fungi. Okay, so the answer to that question, and I'll repeat it because I don't know if you all hear it, is, let me do this slide, then I'll get to the next slide, and then I'll repeat it. So I make these piles on someplace. It can be actually on the forest edge, and in that case, if some tree roots come up into the pile, or raspberry canes, they might put some mycorrhizal spores in that pile, but that's not like a really efficient way to do it, so I don't really even consider that relevant. The pile's going to sit because non-disturbance is where fungi take off. We're going to be talking about my holistic sprays, which include different seed oils for the fatty acid component. So when you think of spraying, think, I'm spraying so I don't get pests, I don't get disease. I spray my compost pile because the fatty acids fuel the fungal dynamic. We're going to get into that. If you came and visited me on a spray day, I might spray you because I think it's just good for everything. But we'll get into that mindset. Another thing I do is I spread compost post-harvest as leaves start to fall. And I indicated that's tying into the fall feeder root flush, but it's also helping to make sure whatever leaves fell decompose, because that's where disease inoculum overwinters. Knowing that I'm going to be doing that in somewhere between mid-October and early November, back in August, if I'm thinking, well, I'd like to get some more calcium out there, and I'm going to do that by using gypsum. If I take that bag of gypsum and I dump it over that pile of orchard compost in the making and just roughly fork it in, I give the organisms that make up the compost food web 6 to 8 weeks to start to break that material down and take it in, and it's a more effective delivery system of the soil amendment. So the principle is you just, rather than spreading 8 bags of gypsum, I get the same calcium uptake because I deliver it through the microbes through my compost pile. Very kind of coarse sense of that. This is what gets into your question. So your question was, you buy commercially made compost, it's been through the windrow process, it's cooled down, so if it was done properly and the temperature was monitored, it didn't have to be overcooked. It's just, I know examples of overcooked compost, but there are really good compost makers who understand that. To add to that fungal component, is it proper to take that mature compost and mix it with the raw meal chip wood and now let it sit again? And the answer is probably yes, but I'm predicating that answer on the fact that once compost is finished, microbial diversity continues to increase for up to 6 months. So that fits my cycle if I'm using it in like 6 months' time, maybe 9 months. But if my orchard compost pile is going to sit a longer time, then I probably wanted rougher compost to begin with because I didn't want to get past the point of maturity so much that I start to lose microbial diversity. So I haven't made it with finished compost. And I think that a really savvy compost maker, I'm thinking of my friend Carl Hammer, he has Vermont compost. You might have seen his potting mix. He just knows so much about organisms and who fuels what, and he uses I think it's yellow birch bark as part of his basic compost recipe. There you're getting into someone who's savvy enough to also start making fungal compost. His already is going in a slightly fungal direction. So there's a realm of compost makers out there. It would be more bacterial dominant to begin with, and that's okay. I just don't want it to be so mature that you're already getting past that increase of diversity in terms of the microbes to let it sit more. I don't want you to lose what it does have. So now let's look at what does it take to replenish an orchard ecosystem where you're removing a crop. So this is looking more at the nutrient aspect than the microbial diversity. So it is said that it takes 2 tons of compost per acre of fruit orchard to achieve that. Well, okay, what does 2 tons look like? Or even, what does an acre look like? It's kind of rough to envision. Now, 2 tons, if it's not overly saturated, is essentially 4 cubic yards of compost. So if you have that sense, you have a spatial sense of it now. Let's go back to what I talked about when I said, in my example, trees on a 16 by 24 foot spacing. That means the tree has an 8-foot radius. So you can draw that circle around me. It turns out that on that spacing, it's approximately 110 trees per acre. We're going to make math simple and call that 100. And if we divide that 100 into that 4 cubic yards, it's essentially 1.5 5-gallon buckets worth of compost that I throw over the fungal duff zone of that tree with an 8-foot radius. So your typical freestanding tree needs somewhere between 1 to 2 5-gallon buckets worth of compost to achieve that spreading of 2 tons per acre. I don't go and fill a bucket for each tree and measure it. I just know that that looks like the 6 to 8 shovelfuls. And as you see in this picture, I'm not making piles. I want to throw it, spread it across that whole fungal duff zone because I want to help decompose leaves, and I want those nutrients that are bioavailable because of the action of the compost food web to tie right into what's taking place with the fall feed or root flush. So if you have dwarfing trees, that math changes. You don't put 2 buckets worth on one dwarf tree with a 3-foot radius or a 2-foot radius, but you get the idea of how to think about it. So now we're going to get into the concept of soil testing, soil analysis, and it involves numbers. Some people get really, really excited about numbers. There's useful things to learn in them, but I don't want to lose sight of the biology as the real driver. So as we talk about this, I'll try to keep coming back to that. Charles Walters started the Acres USA, the magazine, and the from which the eco-farm movement really launched itself, and there's an Acres conference in different places. Some of you have probably been to an Acres conference. And he talked about plants in touch with balanced nutrition provide their own protection from the pests and disease attack. We've been talking about that this morning. Where does balanced nutrition comes from? Not so much you and your compost spreading and throwing azomite clay on the compost pile, or maybe even out in the orchard, or the amendments that you add at the time of planting. Plants' balanced nutrition comes from the whole fungal network in the plant community making intelligent choices of what's needed where. So again, I said arrogantly earlier on, I'm the captain of this team. I like that the team is actually more intelligent than I am. And again, my job is just not to screw it up. And the whole business of protection, that's phytochemistry, that's healthy plant metabolism, that's not having those simple sugars and amino acids in the sap so that diseases don't run rampant and pests, when they come, don't find a substrate to really reproduce in a huge, huge way. Now the whole pest thing is going to become a little more complicated because we're not just growing foliage. Sometimes, some years it seems like I'm just growing foliage, but ideally we're growing fruit, and that's going to draw in some higher order insects, and we're going to get into that aspect. But all this fits with what we've been talking. So when we test the soil and you follow how to go about that, you're taking 12 to 16 or 20 random samples, mixing them together to get an idea of what's happening in the top 4 inches of soil, or if you're doing a subsoil sample that's taken deeper. The lab's going to take that soil and extract the mineral aspects with acids, and it's going to lead to differing recommendations depending on the philosophy really of the lab where you're sending your soil sample. And that comes down to analyzing that soil sample for maximum yields, or analyzing that soil sample and considering fertility ratios so that you are growing crops with more resistance to pests and disease. So I'm going to go with this group. And it isn't that this group doesn't give you useful information, but they don't do some of the number aspects that I actually utilize to make sense of it all. So this group of soil labs are really following the idea of cation exchange capacity. And they're going to look at things like the base saturation ratios of calcium, magnesium, and potassium. Those are words you don't necessarily see on certain labs in this group. So we're looking to get pH somewhere in the middle 6s, because that's where the most nutrients are exchanged. Now, pH is not the whole enchilada. pH is just like a way we talk about this. We're going to learn a different way to zero in on that part. Organic matter is really relevant to a healthy biology. So getting it up to 3%, if not 5%, if not higher, is absolutely a goal. If you start at half or 1%, that's a weak soil. I don't need to test it in a lab to see that. I can see the growth response of plants. But what I'm really interested in is this idea of cation balance. And some of these numbers are in your handout, so you know that. So here I'm talking about the positively charged ions that attach to the transfer sites on biochar and soil particles, soil aggregates. And this is primarily calcium, magnesium, and potassium. And in order to judge ratios between them, we start by establishing a calcium baseline. So calcium there's going to be a reading on a soil analysis of, I thought my screen was flickering again, but I stole this slide because I don't do this kind of stuff where things move. Again, I can be easily thrown off, even by something I've seen 100 times. Calcium baseline. So you're going to get a result for calcium that's either in pounds per acre or parts per million. And if the lab that you're working with gave you a result in parts per million, if you multiply it by 2, you now have the approximate pounds per acre. So the calcium baseline that I want to see on a soil test starts at 2,000 pounds per acre. And the investment in calcium plays so many roles in cell strength, in resisting rots, in the keeping ability of your fruit. Calcium is like the best investment you can make as far as an outside input goes for soil health, for the biology to utilize. And pushing that up to even as much as 4,000 pounds per acre can be a worthy investment, as long as you're keeping the other ratios in balance with that. But you have to have a sense of a beginning point, and 2,000 pounds describes that. Then there's the fact that some people have soils with a low CEC number, that cation exchange capacity, and when that number is 2, 3, 4, 5, 6, you have a very nutrient porous soil, which looks like sand. So you don't even need a soil test to know if you have a sandy soil. Well, magnesium helps pull soil particles a little closer together. So in that kind of soil, we're going to have a little bit more magnesium than we might want in a more compacted soil. A soil with a high CEC number, talking now like 14, 15, 16, 20 and up, that's a clay soil. And you also don't need to test that. You have a compacted soil, but some extra calcium helps spread particles apart. So those principles will be woven into these numbers, which are based on what's called the base saturation ratios on your soil test. So you'll have a percent saturation for calcium and magnesium and potassium. That's the order of these numbers. The first number is calcium, the second number is magnesium, the third is potassium. When there is a serious deficiency of magnesium or an excessive amount of magnesium, that will block the uptake of calcium, which is so important to so many aspects of fruit growing. And so the ideal is to have a 7-to-1 ratio with them. So ideally, calcium is going to be a 70% base saturation, and magnesium is going to be a 10% base saturation. Now I'm talking also about a nice loamy soil, that middle range of CEC numbers, 7, 8, 9, 10, 11, 12. It's not sand, it's not clay. The third number I'm going to explain in a few more slides. That's potassium. In a sandy soil, that extra charge of magnesium is reflected by letting that second number be a little bit higher, ideally. And again, these are numbers. It's not like you're going to purgatory if you don't get your sandy soil to 68, 16, 3. You have to be let loose a little bit here. It took me a while to do that, because remember, I have a degree in engineering, so I was like a numbers person. With the heavier clay soil, we want some more calcium. So that's all that's about. But when you analyze your soil, and you get that first measure of the pH, or maybe you use a pH kit, and it tells you your pH is 5, and maybe the lab suggests you need to add 2 tons per acre of lime, you have to understand that that choice of lime becomes really relevant, because high calcitic lime has very little magnesium. So if your magnesium is already in the right place, and you need calcium and you need to up the pH, you want high calcitic lime. If in that same scenario, your magnesium is lacking, you want dolomitic lime, because usually 12 to 20% of the content of dolomitic lime is magnesium. So you don't want to skew it the wrong way because you chose the wrong lime. Then another aspect, I said 2 tons per acre. If you're breaking ground and you're going to till, maybe you're dealing with an invasive grass like quackgrass, or maybe there's a lot of poison ivy, I don't know what the scenario is, or it's already a degraded soil, it's that monocrop cornfield. You're going to till so that you can incorporate the lime deeper. You might go with that full recommendation to begin with. But if you've already got some decent plants there and you're just tilling swaths, you may find that spreading it over a spring application and a fall application, and even into the next year, you'll get more uptake of the calcium by the organisms than you will if you just really wump it to begin with. So I would never put 2 tons as a surface application, and that's going to come in the later years once the trees are established, and you soil test again 3 years later, and you see I still need to get the pH back up. Then I might be doing a rate of 400 or 500 pounds at the most, and that's on the surface. It's not being incorporated. So there's other things we could talk about here, but that's enough unless you have a question. So one of the amendments I really like, particularly when you start to get the pH in that right range, but you still want to get the calcium baseline higher, is gypsum. So gypsum is one of the ways, especially to work with a more clayey soil. This was called soil plaster? That's in the south. It just ameliorates, it helps spread that clay particles apart. But there's also a lot of fruit, particular varieties, that are subject to calcium deficiencies. So the 2 main categories of that, we call it a disease, bitter pit. So if you're growing Jonathan apples or Northern Spy or Baldwin, or right now they're not coming to mind, and you see these little quirky shrunken spots on the surface of the skin, and maybe you didn't see it when you picked the apples, but they develop in storage, that was a fruit that didn't get all the calcium that it needed. And it isn't necessarily that you had a deficiency of calcium. Something blocked the uptake of that. And so increasing the baseline can help. The other category is if you grow Honeycrisp. And Honeycrisp, that's like this really popular apple right now, and people pay more for it, so you're drawn to probably grow it if you're doing this commercially. Honeycrisp has real calcium issues, and the leaves turn yellow on the tips at the height of summer. It's also subject to bitter pit. Trees that I see bitter pit on are my Honeycrisp. In the spring, I almost always say, yep, you need 5 or 10 pounds of gypsum. This is a full-size tree now, just because I want that calcium. But I also need to keep sulfur up there, because sulfur is really important in protein synthesis. Now, back in the 60s, 70s, a French agronomist named Francis Charbachot was looking at not yields, but what are the fertility ratios when I see a crop with less disease versus a crop with more disease. And he called his theory trophobiosis, but it was basically deficiency of balanced nutrition. And he recognized how important protein synthesis was for all the reasons I talked about. That this was really what was going on when you saw a lot of pests or a lot of disease scenarios. And out of that research, he discovered that the ratio between calcium and that third number, the potassium leg, ideally is on the order of 20 to 1. And if it's less than that or greater than that, you see typically more of those amino acids in the sap that the spotting fungal disease feeds off of. So that's the basis of why it was 70, 10, 3 plus, because I'm trying to keep to that 20 to 1, because if my paying attention to that aspect lessens the chance for apple scab to take off, I have a whole lot less fungiciding to do. I'm not going to be fungiciding, but we'll talk about it. And asparagine is just the name of one of those amino acids. It's a combination of amino acids. Now, trace minerals. I have talked about how mineralization is important. Molybdenum, let's take that one. There we have the nitrate reductase enzyme. So that's that process of converting nitrate back to ammonium. It ties to how much is that crop subject to rots. You know, we're going to talk about specific strategies for rots, but I'm counting on molybdenum being available in that soil ecosystem, primarily by my generalist cooking approach with azomite clay, but even more so, the fungi being involved there. Cobalt deficiency is often tied to a lot of apple scab. You don't need to know this stuff. I mean, this comes out of extension research, and it's good and it's useful. I use the term generalist cook. So some more of what I do. So kelp meal, we're going to be talking about seaweed in my sprays, but this is something I also occasionally add a sprinkling to the compost pile. And primarily, in the winter, we have sheep. Besides hay, I'll give them a handful of alfalfa pellets with a sprinkling of kelp meal, because it goes into the poop, which becomes part of the compost pile. It all comes around again, and it keeps them healthier. The azomite clay as a layer on compost. If, let's say I have a pear tree, and it's looking, any tree that's looking weak, typically I'll say, okay, 5 pounds of azomite clay in the spring before the spring feeder root flush, maybe even 10 pounds. And sometimes I can jumpstart things that were going in a bad direction back onto more solid ground. You know, don't forget the ramial chipped wood or the orchard compost, but that's the way I think. I'm not testing every minute. I primarily use dehydrated ocean water in foliar sprays, but some people buy a product called C90. They might feed it to their animals. They might do a slight layer on their compost. There's some concerns with salt with that, but there's different ways to go about this without testing to the micro degree every time you make a move. I'm also going to tie minerals into the foliar spray plan, and when we do that this afternoon, it's going to all weave together, so hopefully it'll come across as coherent to you. But I'm going to do that at critical points in the growth cycle, when there's a huge demand on the fruit tree, maybe it's going into bloom, maybe it's growing pollen tubes that are going to become the seeds in the fruit. Maybe it is at fruit set, and it's both developing the fruit, but also developing flower cells for next year. All the while, this is also overlapping with when most diseases are trying to get a hold. So that little extra charge of nutrition at these critical points of influence becomes relevant. And I'll explain micropack and seed crop in more detail as choices here. But I'll show you on the calendar of where we're going with this. But again, it's at its core, it's about mineralization. So boron's really important in terms of things like those pollen tubes, making sure the fruit does set. It plays an essential role in the uptake of calcium and also protein synthesis. So in the Northeast, boron is the one trace mineral I keep special tabs on. I don't necessarily test my generalist cooking to take care of. That doesn't mean I won't look at copper or some of the other trace minerals if they're seriously deficient on my first round of soil testing. But boron is the one that a few years later might start to go down again. And boron is one of those things that, let's say your soil analysis says you need 2 pounds of actual boron per acre. So again, just like the 2 tons of compost, how does that look under a tree? Well, what does 2 pounds of boron look like? So one of the sources of boron is you go to a box store or your grocery store, and in the laundry detergent there's borax. Borax is like 11.3% actual boron. And that 2 pounds looks like 17.7 pounds of borax. This is why I wake up early in the morning to go through my program, so like I got these numbers, because it's not like 17.7 pounds of borax. No. Let's go to my my notion of a tree with an 8-foot radius. What does that 17.7 pounds look like? 2 ounces. Now, this is probably the one time when it's appropriate to put on tights and put on a fairy outfit, because 2 ounces distributed across that circle needs to be evenly distributed, and it needs to be sprinkled like soil, like fairy dust. Boron in excess is herbicidal. Here's one of my greatest screw-ups ever. This is sometimes how I'm most helpful to people. There's a foliar boron product called Solubor. And Solubor is typically applied at pink and at petal fall. And it's at a certain rate so that you don't apply to excess. And when I was using Solubor in the late 90s, another product became available that's often a very important tool in the management of a certain insect pest called the plum cucullia. And we're going to get into the insect portion. And Surround, this is a refined clay product that flakes off on the insect. And so it turned out that my timing was such that I tank mixed Solubor and Surround, and that was okay, no problem there. And I went through the orchard and I did the approximate rate, so I wasn't overdoing it on each tree. And then I had whatever 15 gallons of spray left, and knowing that the clay, you can build up layers, it becomes more effective. I totally forgot about the Solubor in that tank mix. So I went to like my best looking 30 trees in one part of the orchard and gave them that extra coat of clay. The next morning, those trees had no leaves. They totally defoliated because of the boron in the Solubor, which they didn't tell you to apply like double, triple rates. You know, that was my screw up, but my head got lost in another place. I was thinking about another aspect. But boron is important, but it doesn't want to be overdone. So sulfur, I have this, I've tried to say I grow biologically, or I might say I grow holistically. And then sometimes I say organic growers. And then sometimes I refer to chemical growers, and I might say IPM growers. It refers to integrated pest management. Or sometimes I might call that conventional growers, even though just because it's been done for 50, 60 years doesn't necessarily seem that conventional to me. But then I use this other term too, conventional organic. And in conventional organic, we're going to learn about the mineral fungicides that you're allowed to use on a certified organic farm, sulfur, copper. In my early days, I would spray copper 20 to 30 times. Not copper, sorry. Sulfur 20 to 30 times for disease control. You know, this is before I learned about healthy plant metabolism, what have you. And so the sulfur component of my soil was always up there, if not high, because sulfur washes down into the soil. I no longer use sulfur at all, and I kind of have to keep some tabs on it. So when I apply gypsum, I'm applying sulfur in the sulfate form, which is the best in terms of the biology. And sometimes I just have to think I need to do a sulfur investment because I'm no longer regularly spraying sulfur. And sulfur wants to be like 25 parts per million. That's the place that really facilitates protein synthesis. So I don't know what an Indiana soil test looks like per se, but that's something I think about. That's another one of those things to watch. So the timing of spreading soil amendments, it's basically early spring, preceding the spring feeder root flush, or in the fall, whether it's prior to harvest or after harvest, because the fall feeder root flush lasts on the order of 14 to 16 weeks. So the spring only lasts 3 to 4 weeks. The fall feeder root flush goes right on into under snow cover until the ground freezes. That's when if you're going to invest in a soil amendment or you're going to be doing lime application, you do it so that there's time for the organisms to take in the nutrients so you can benefit from it that growing season in terms of the feeder root flush. If you utilize rock dust, that can be almost any time because this is not something that's readily soluble. And what I want to point out here is the one investment that I've been really impressed by, and I haven't done it yet, is if you can lock into some of the volcanic derived basalt dust, that seems to be a really amazing investment to make in fruit trees because of the minerals made available and some of the energetics of basalt dust. But for me, this has been more or less going to the quarry. There's dust by the grinder. It's basically granite dust. So that's been my use of rock dust. But you might have something in your bioregion that you can tap into as a way of remineralizing the soil through rock dust. The tree radius idea. You know, when I plant a little tree and the soil hole I dig is like 3 foot in diameter, I'm thinking about maybe up to a 4 foot radius around that tree I'm amending, and then over time I'll add to it. This is kind of a thrifty Yankee thing. I can't make the whole acre perfect, but I start to build the fungal duff zone. Similarly, I might make investments in soil amendments down the line. And that can save money in that beginning period when you're buying the trees and you're buying deer fence. No, you don't necessarily need azomite everywhere. You just invest in that beginning zone. And once the fungal ecosystem itself is launched, you may not need azomite further out unless you see a tree that's a little bit sicker. So you get this idea. It's like, don't want to just constantly buy in things. We want to use it wisely and prudently, but it's really about fungal ecosystem, the biology delivering it, and then things expand. So this idea of soil chemistry, not losing sense of the biology, that's where nutrient density comes from. That's where resistance to disease comes from. This is a picture of a blueberry grower's farm. I think he calls it Sunset Valley. His name is Bob Wilt. He's in a place where there's a lot of other blueberry growers, and they are growing more conventionally and dealing with spotted-winged Drosophila, that fruit fly we talked about earlier, consistently throughout the growing season. His orchard is located in the same place. He sees some spotted-winged Drosophila, doesn't consider it an issue. But what he's doing is he's growing a diverse plant community in the aisles. He's using things like liquid fish and seaweed, and the things I'm going to talk about as foliar elicitors of the induced systemic response. And all that together not only makes more resistant crop, but makes for a much more nutrient-dense tasting crop. You know, that's the real key. I'm going to get into that tomorrow when I talk about the great mineral debate. For me, nutrient density correlates entirely to life density in the soil. We're back to the biology. When I talked about healthy plant metabolism, I was emphasizing how that fungal-dominated ecosystem is so important. And when I gave you the example of the feeder root, and I said a root all by itself can just slurp up soluble ions, well, in a biologically rich rhizosphere, where there's the mycorrhizal fungi and the saprotrophic fungi and all sorts of bacteria, the plant starts to get part of its nutrition in a partially built form. And I'll get into this more tomorrow, but the relevance of this is that's a phenomenal way to reserve energy to get to the point where you produce those resistance metabolites. Again, you don't have to know all these details, but mineralization, fungal connection, that's what we're really shooting for. And it's relevant to us. Work done by Allison Mitchell at the University of California, Davis. They looked at the antioxidant content of crops, including fruits. I think it was primarily strawberries. The antioxidant content of crops grown in an organic system versus a fungicide, over-fungicided system. And when you medicate a plant to take care of its potential issues from pests and disease, the plant essentially shuts down its phytochemistry aspects, and that fungicide cloud allows the crop to be grown without the molds taking over, without the fungal spotting diseases taking over. But the plant, the crop itself, lacks the phytochemical, oomph. That's bad. I just gave this talk on Sunday in Ontario. Maybe I didn't have enough downtime. Oomph is what I'm trying to say. Which is what our bodies evolved with. You know, we're a species that evolved eating wild apples, wild nuts, the occasional mastodon. And those phytochemicals allowed us to ward off degenerative disease. Now we have crops grown in a fungicide cloud on mineral depleted soil, and our hospitals are filled with the need to deal with degenerative disease from without rather than from within. It all comes back around. At Cornell, they recognized that the phytochemicals found, the proanthocyanins found in the skin of the apple, significantly knocked back the things like liver and colon cancers. And so they took that information and they started to synthesize those proanthocyanins so they could have a pill to help people get beyond these cancers. And I'm thinking, why aren't they just telling people to eat more fruit from grown in living soil systems? Because that's where the real oomph comes from in terms of fighting cancers and degenerative disease. So Rudolf Steiner gave some lectures known as the agricultural lectures in 1924 in Austria that became the basis of biodynamic farming. And Steiner's motivation at the time in 1924, he would just recognize that people were not thinking as well. They weren't as spiritually perceptive because you need good nutrition to build that aspect of the human spirit. And all I can say is 100 years later, we are certainly not gaining on that front in terms of our perception and the choices that we make. This is really important. How we grow food comes back at us in so many different ways. Let's talk about different plants in the ecosystem. What does the clock say, 11 or 12? I can't. I'm going at a slower pace in Canada. Okay, let's up it. This is what happens when I have that extra hour to 5. It's like your pace is like, what should you be doing? So let's just set the stage for ecosystem connections, and then we'll come back to that. So the other plants, I've been referring to the orchard ecosystem as a plant community. The other plants play a role both in the fertility loop of the orchard and in the diversity of insects that work to our benefit. So in permaculture, you identify different stacking functions that plants, they're not just a nitrogen fixer, let's say. Their flowers also attract an adult beneficial that helps with insects. Something like narcissus bulbs, daffodils. Voles don't like that. So some people plant a small ring of daffodils, maybe 6 daffodils around their tree, a foot or 2 out, which become clumps. It looks really pretty, but it also becomes a place that voles are not going to feed and hang out so much for the trunk within. I have another grower who has a real issue with pine voles. So voles are not mice. They have stubbier tails, and there's many types, but the primary 2 are the meadow vole, which is more of a surface mammal. Doesn't mean it won't tunnel an inch or 2, but it's more on the surface. That's what we put the trunk guards up to prevent the bark from being gnawed. The pine vole, if you never heard of it, I hope I'm not bringing it to you by mentioning it. The pine vole goes deep, and I went into this guy's orchard for the first time, and we were pruning and talking about training the tree, and we'd come to these trees that were like loose in the ground, and you could pull it up, and the root system looked like a carrot, because everything had been eaten and gnawed their way. It's the absolute worst. And flashing back to where I am, he has this fence with like wire embedded 2 to 3 feet down. This is a serious person to keep groundhogs from getting in there. But the voles love the habitat under the lower bar of the fence, so it's a protected place. And then they come into the orchard to make carrots of the root system. And besides, like that little Russell Terrier that goes after them, or he's going to put up an owl house, and he has hawk stations. So just plant daffodils, make that fence area somewhere they don't want to be. And, you know, understanding the different ways that different plants work can really help you change dynamics of certain things. So one group of plant that's really important for the fertility loop are the taprooted herbs and flowers that basically through their either broad-reaching root system or deep, especially deep, are grabbing nutrients in the subsoil that are brought up into the leaf and the stem of the plant up top, which when it falls over going into the dormant season, decays on the surface of the soil, where the greatest feeder root and mycorrhizal fungal activity is going to occur when we're going through those cycles. So various taprooted plants are noted for, in some cases, bringing up specific nutrients. So chicory is considered a zinc accumulator. And you can go through those lists. My perspective here is the more diversity, the better, because plants are all doing different things. And one of my favorite plants to utilize in a freestanding orchard system, so I just use those words to distinguish from a dwarf orchard planting, where the trees can't take competition as much, to a tree that's freestanding, and so 6, 7, 8 feet out in that 8-foot radius, I plant comfrey. So comfrey is a medicinal herb. It gets to be about 2.5, 3 feet tall, and it has a deep root system, which brings up minerals, particularly calcium. I guess I should give the disclaimer. I'm telling you all the benefits of comfrey, and I'm going to give you some nuance to go with that. And I'm being really honest. If you plant comfrey, it'll probably be there for the rest of your life and beyond. So if you change your mind, you can't come back at me and say, you didn't tell us. I'm telling you now that this is a kind of a permanent life choice. Not necessarily, but it's a hard thing to get rid of. What's really nice about comfrey, besides bringing those nutrients up, that wide growth of leaf up top means there's room in the humus, The one thing to understand is comfrey flowers right after the apples. That's great for the bumblebees. You have to think about successive bloom. But flowers become fertile seeds. And if you get that kind of comfrey, the comfrey from Europe, you absolutely have to cut it before the seed becomes mature, because otherwise your whole ecosystem will go from your goal of making it diverse to being all comfrey. So you don't buy comfrey seed to start comfrey. You need to get roots of the Bocking cultivars, B-O-C-K-I-N-G, which was a cross of European comfrey, Xiphitum officinalis, with Siberian comfrey. And the Bocking cultivars do not set fertile seed. And the advantage of this works this way. I'm a comfrey plant. I grow, and whether I naturally fall over or you as a grower push it in a certain direction, the fallen over part of the plant stays alive, and so it actually does suppress the grasses that are trying to move in under the tree canopy, because I don't want that dense grass canopy under the tree. And that is what I mean by a living mulch. So if you have a seeded comfrey and you have to cut it, what you cut will decompose rapidly, and it doesn't suppress that growth the way the Bocking cultivar can. Another thing about comfrey, any plants with rough stubble, so when I mow the orchard in the fall, rough stubble or leaving herbs like lemon balm or mints in the garden, that's a place for a lot of beneficials overwinter. And learning to leave things a little rougher is going to help you build up beneficial populations. I'm going to use the comfrey as well in fermented plant extracts to get my foliar calcium within the loop of my farm. And all of this is what I call the taproot fertility loop. You know, there's dandelion, humble little dandelion. Well, dandelion brings potassium up. It doesn't go that deep, but it still concentrates some potassium out in the orchard. All these different plants play a different role. So we have lunch, and that's 1 hour, so we'll resume at 1. I'll answer one question. I will leave the PDF version of this with, do you do that? Okay, so the answer is yes. Well, the PDF version I approve, yes. So I have that to provide Purdue, and they can in turn make it available to conference growers. Okay, lunch.